Okay, so our hybrid functions are a composition of functions, okay, where they're each being defined. If you have a look at the example here, each of these rules have been defined over separate domains. So this one, x squared plus 5, just where x is greater than 0. The graph of 5 minus x between -3 and 0. And the graph of y equals 8 between -3 to infinity. So if we sketch each of these, the graph of x squared plus 5. So the graph of x squared plus 5 is something like this. That's the full graph. Now if we consider where the function speaks of only where the x values are greater than 0, beauty of my friction pen, we can see now that really with a hollow dot at the point 5, so that's that section of the graph there in blue, okay? So we're looking at the straight line now between -3 and 0 for the graph of 5 minus x. So -3 is that point there. There's -3 to 0 there. So that's the section there. And I'll sketch the graph of 5 minus x. Well, at x equal to 0, y is equal to 5. And at x equal to -3, y is equal to 5 minus -3, which is 8. So I get the point -3, 8, 5, 6, 7, 8. So it's up here. Solid points for both. So we can see now that it becomes continuous, and a little impromptu ruler. There's the graph of 5 minus x between -3 and 0. We've now got the line y equals 8 from -3 onwards. So that's the point -3, 8, which means where x is less than -3, it's this section here, isn't it? It's all this here. These are the x values less than -3, which means I'm just going to draw that graph in that section there. Okay, so it's just really a case of drawing multiple graphs over specific domains.